July 25th, 1944. 9:38 in the morning. Normandy, France. Lieutenant General Fritz Bayerlein, commander of the Panzer Lehr division, the Wehrmacht's finest armored training division, an elite formation built from the best instructors and equipment the German military possessed, stands in his command bunker watching the clock. 6 weeks of continuous fighting since the Allied landings. 6 weeks of holding positions against everything the Americans could throw at them. His division is still intact, still combat effective, still the Panzer Lehr. The American artillery has just gone silent. After weeks of constant harassing fire, the guns have stopped. Bayerlein notices the silence immediately. It is strange, suspiciously strange, the kind of silence that doesn't feel like a pause. It feels like a held breath. He has 60 seconds before he understands what the silence actually was. It was the last thing his soldiers would hear before the earth became something else entirely. What happened in the next few minutes was not an artillery barrage in any sense that Bayerlein or any of his officers had been trained to understand. It was not a bombardment. It was something that had never existed before in the history of warfare. A mathematical operation applied to human beings. The Industrial Revolution expressed as organized destruction at a scale and precision that the German military, with all its tactical genius and decades of refined doctrine, had no conceptual framework to comprehend. In a single day, Panzer Lehr, veterans of Africa and the Eastern Front, men who had survived Stalingrad, men who had been specifically selected as the Wehrmacht's best, would lose more than 70% of its combat strength, not over days or weeks of attrition, in a single day. To understand how that was possible, you have to understand what the Americans had built, why the Germans couldn't replicate it, and why the gap between the two systems was not measured in equipment or courage or tactical sophistication, but in something the German military culture had systematically undervalued: organizational learning applied at industrial scale. Start with the German Army in 1944. In almost every conventional measure of military effectiveness, it was the finest ground force on the planet. The Germans had invented blitzkrieg. They had taken France in 6 weeks. They had reached the outskirts of Moscow. Their officer corps, trained in the tradition of Auftragstaktik, mission-oriented tactics that gave subordinate commanders the authority and expectation to use their judgment rather than wait for orders, was considered the gold standard of military leadership by armies around the world. German artillery doctrine had been refined over decades. The concept of Schwerpunkt, concentrating fire at the decisive point, fast and precise strikes coordinated closely between forward observers and gun batteries, had worked in Poland, worked in France, worked across the opening years of the Eastern Front. When German intelligence received early reports about American artillery methods in North Africa, the response at the highest levels of command was something close to dismissal. Kasserine Pass in February 1943 seemed to justify that dismissal. So American artillery had failed badly there, scattered batteries unable to coordinate their fire, responding too slowly, delivering too little at the wrong moments. The Germans had crushed the Americans at Kasserine and drawn the conclusion that seemed obvious from what they had observed. American soldiers had good equipment and poor military professionalism. The conclusion was wrong in almost every particular, but it was the conclusion German commanders took away from Kasserine, and it would shape their expectations about American capabilities until those capabilities demonstrated themselves in terms that could not be rationalized away. What German intelligence missed was that the Americans were doing what the German military, at the peak of its confidence, had stopped doing. They were learning. They were analyzing what had failed at Kasserine with the systematic rigor of an engineering problem, identifying the specific failures and developing solutions. And they were applying to warfare the organizational capability that American industry had been developing for decades. The ability to coordinate complex processes across large numbers of interdependent components to achieve outcomes that none of the components could achieve individually. The revolution that made July 25, 1944 possible had been underway at Fort Sill, Oklahoma since the 1930s. A group of officers led by Major Carlos Brewer and Major Orlando Ward had been working on a question that sounds simple but had profound implications. What if artillery stopped being thought of as individual batteries firing at individual targets and started being thought of as a system? So the first element of that system was the Fire Direction Center. Picture not a single officer with binoculars and a map doing calculations in his head, but an entire computational facility. Trained personnel, firing tables, slide rules, graphical plotting boards, capable of calculating firing solutions for dozens of batteries simultaneously and coordinating their fire against a single target or multiple targets in real time. German forward observers worked with 1 or 2 batteries. An American forward observer could call in fire from an entire corps. Dozens of batteries at varying distances and positions, all coordinated through the FDC to deliver their fire exactly where it was needed, exactly when it was needed. The second element was communications infrastructure, built to a standard of redundancy the Germans never matched. An American infantry division could lay 5,000 kilometers of telephone wire in a month of active fighting, supplemented by SCR 610 radios with reliable ranges of 8 kilometers. The system was designed with the explicit assumption that primary communications would fail under combat conditions, and that when they failed, backup systems needed to be operational immediately. German communications failed constantly in Normandy. Artillery observers lost contact with their batteries. Batteries lost contact with their headquarters. Headquarters lost contact with each other. When American communications failed, there was a backup line. When that failed, there was another one. The redundancy wasn't accidental. It was doctrine. The third element was something that the German war economy, by 1944, could not provide at any price: standardized ammunition. Every 105mm howitzer shell produced in a factory in Pennsylvania had identical ballistic characteristics to a shell produced in California. Every charge burned identically. Every fuse performed identically. This sounds like a manufacturing detail, but in artillery it is fundamental. A fire mission calculated for a specific shell traveling at a specific velocity with a specific drag profile only works if the shell actually behaves the way the calculation assumes it will. American gunners could calculate trajectory accurately because the shell in the chamber would behave exactly as the firing table said it would. German ammunition in 1944 was being produced by slave laborers in dispersed workshops under conditions of deliberate sabotage and supply shortages that made consistency impossible. Quality varied batch to batch. At Anzio, 70% of German 170mm shells were documented as duds in a single action, not fired ineffectively, but not exploding at all. German batteries had to conduct registration fire, firing ranging rounds to calibrate for each new batch of ammunition, a process that cost time and revealed their positions. American gunners calculated their firing solutions and trusted them. German gunners calculated their firing solutions and hoped. The fourth element was the time-on-target technique itself. Here is the fundamental insight. Artillery fired sequentially arrives sequentially. The first shell lands, so the defenders hear it, understand what's coming, and move to cover. The second shell lands on positions that are already emptying. Research conducted by the U.S. Army in the post-war period quantified exactly how rapidly this protective instinct operates. At the moment of the first explosion, 58% of soldiers in the open are still standing. 33% have already taken covered positions. 9% have gone flat, but without cover. After 2 seconds, only 29% are still standing. After 8 seconds, the figure approaches 0. Nearly every soldier has gone to ground. Traditional artillery bombardment is, functionally, a warning system. The first shell announces what is coming and gives the defenders time to protect themselves before the rest of it arrives. Time on target eliminates the warning. The technique works by calculating flight time for every battery that will participate in a mission, from the 5-kilometer battery, whose 105mm shells take 23 seconds in flight, to the 25-kilometer battery, whose 240mm shells take over a minute. You then give the order to open fire in reverse order of flight time. The farthest batteries fire first. The closest batteries fire last. Every shell from every battery arrives at the target within the same 1-second window. Not 1 minute, not 10 seconds. 1 second. When 58% of your soldiers are standing upright, they all die simultaneously. There is no first shell. There are only all the shells at once. The casualty reduction that traditional bombardment produces, because defenders go to ground after the first rounds, simply does not occur. The mathematical consequence is not a marginal improvement in effectiveness. It is a fundamental change in what artillery is, the difference between a weapon that warns and a weapon that executes. On July 25, 1944, General Omar Bradley concentrated what was at that point the largest artillery grouping the American Army had ever assembled in Europe. 1,100 guns, from 105mm howitzers to 240mm heavy artillery pieces. 522 guns from the 7th and 8th Corps alone. 170,000 shells allocated for the operation. 140,000 for 7th Corps, 27,000 for 8th. The target was a rectangle 6.5 kilometers wide and 2.5 kilometers deep south of the Saint-Lô-Perrier road. Inside that rectangle, Panzer Lehr and elements of the 5th Parachute Division. Approximately 5,000 soldiers in fortified positions. First came the carpet bombing, 1,500 heavy bombers, B-17 and B-24, dropping 3,300 tons of bombs and 60,000 incendiary devices across a 12-kilometer zone. 5,000 bombs per square kilometer. Then, at 9:38, the artillery. Bayerlein's own words, written in his after-action account, describe what happened with the specificity of a man trying to make sense of an experience for which no existing language was adequate. The bombers came like on a conveyor belt. Bomb carpets fell back and forth. Artillery positions were destroyed. Tanks overturned and buried. Infantry positions leveled to the ground. All roads and paths destroyed. By noon, the entire area resembled a lunar landscape. Craters touched each other at their edges. All communications were severed. No command was possible. And then, the shock effect on the troops was indescribable. Several of my men went insane and ran around in the open until they were cut down by shrapnel. More than 70% of my troops were killed, wounded, driven mad, or shell-shocked. Panzer Lehr, the Wehrmacht's elite, 2,200 combat-ready soldiers, and 45 armored vehicles at the start of July 25th, ceased to exist as a fighting unit before the day was over. The division that had been assembled from the best the German army had to offer, that had survived Africa and the Eastern Front, that represented the Wehrmacht's highest standard of professional military capability, was destroyed in a single morning by a system it had no capacity to counter and no conceptual framework to fully comprehend. The same technique applied to Mortain 6 weeks later demonstrated something even more striking: that time on target could stop an offensive as effectively as it could destroy a defensive formation. On August 7th, Hitler ordered Operation Lüttich, a counteroffensive by 4 panzer divisions, including the 1st SS Leibstandarte and 2nd SS Das Reich, tasked with breaking through to Avranches and cutting off Patton's army. This was Germany's last realistic opportunity to change the outcome of the Normandy campaign. 2 artillery observers from the 231st Field Artillery Battalion, Lieutenants Charles Bartz and Robert Weiss, were positioned on Hill 317 above Mortain with a radio and a clear view of every road below. When German columns began moving, they called in fire. The 2nd Infantry Division executed up to 20 time-on-target missions per night. 7 artillery battalions coordinated fire against pre-registered coordinates, assembly areas, approach routes, command posts. German survivors described what they encountered as solid walls of red-hot steel. Not a barrage in the conventional sense, a physical barrier of simultaneous explosions that made movement forward equivalent to walking into something that couldn't be walked into. Field Marshal von Kluge reported to Hitler that continuing the offensive was impossible against such artillery superiority. 700 Americans on Hill, 317, half of whom were eventually killed or wounded, stopped 4 panzer divisions. Not through superior courage, though courage was not lacking, through a radio and access to a system. The Falaise Pocket in August 1944 demonstrated the technique's capacity to turn a route of retreat into a killing ground. After the failure of Operation Lüttich, German forces found themselves encircled, with a single narrow corridor near the town of Falaise as their only exit. American observers were positioned on every hill overlooking every road. Documented time on target missions on the Falaise-Argentan road ran at 30-minute intervals throughout daylight hours. Each mission engaged 10 to 15 batteries simultaneously. General Hans Eberbach, commanding the remnants of Panzer Group West, described a curtain of fire so dense that bringing up reserves or evacuating the wounded was impossible. Moving vehicles meant certain destruction. The road became what German survivors called the corridor of death. Wrecked vehicles, dead horses, and abandoned equipment accumulated in traffic jams that slowed the movement of the formations behind them and made each successive column more vulnerable to the next mission. When the pocket closed on August 21st, 50,000 German soldiers were captured and 10,000 killed. Artillery was documented as the primary cause of casualties, not the infantry closing in around the perimeter, the guns. The Ardennes offensive in December 1944 introduced the final element that completed the system. The proximity fuse, the VT fuse, was a small radar device installed in an artillery shell that detected the ground below the projectile and detonated the warhead at the optimal height, 6 to 15 meters above the surface. 22 million of these fuses were produced during the war. Their effect was to create a lethal radius of shrapnel fragments at head height across an area that no trench or foxhole could protect against. A soldier dug into his shoulders was protected from a shell that impacted the ground nearby. The same shell with a VT fuse detonating 15 meters above him was not something a trench stopped. When VT shells were incorporated into time-on-target salvos, the resulting lethality was qualitatively different from anything that had come before. On December 19th, near Dinant, the 2nd SS Panzer Division, moving in column on a road, was caught by an emergency time-on-target mission. 8 battalions calculated their firing solutions in 4 minutes. The leading battalion of the German column was destroyed in 60 seconds. General Patton, who was not given to understating his army's achievements, but was also not given to fabricating them, wrote afterward that the shell with the funny fuse had decided the Battle of Belgium. A German battalion crossing the Saar River had been practically annihilated, 702 men. German soldiers began refusing to leave covered positions during artillery preparations, not because their courage had failed, because their rational calculation of survival probability was accurate. The German attempt to develop a comparable system, the largest coordinated German artillery effort of the Western campaign, during Operation Nordwind in January 1945, involved 8 batteries and produced a shell arrival spread of 12 seconds. The American standard for time on target was plus or minus 1 second. The difference was not technique. Our German officers understood the mathematics of synchronized fire. They could calculate flight times. The difference was everything that made the mathematics usable: standardized ammunition that behaved as calculated, communications infrastructure that maintained coordination under combat conditions, trained fire direction personnel at every level of the artillery hierarchy, and an industrial base capable of producing the shells to sustain the operations. German artillery ammunition by 1944 varied unpredictably in ballistic performance. German radio networks were constantly intercepted and jammed, and telephone wire was chronically insufficient for the communications burden of complex fire missions. Germany had trained far fewer fire direction specialists than the American system required and produced, because the doctrinal framework that would have identified the need for them had never been developed. And German factories, under constant bombing and labor shortages, could not produce ammunition at the rate that sustained artillery operations required. The system that made time on target effective was built from components that all had to work simultaneously. Germany couldn't provide them. The psychological documentation from German medical services in 1944 and 1945 records a phenomenon that distinguished time on target's effects from conventional bombardment in ways that went beyond physical casualties. Like German soldiers who had endured hours-long Soviet artillery barrages on the Eastern Front, men whose psychological resilience had been demonstrated under conditions that would have broken most human beings, broke after 30 to 60-second time on target salvos. The Eastern Front veterans could survive hours of traditional bombardment because traditional bombardment has a pattern, a rhythm, a buildup. It can be anticipated. A soldier's brain has time to switch into the specific cognitive mode that combat survival requires. The instinct to find cover, to wait, to assess, to act when the moment allows. All of these responses have time to engage. Time on target provides no such time. There is no first shell. There is no rhythm. There is no warning. There is silence. And then there is everything at once. The psychological coping mechanisms that soldiers develop through experience, the internal protocols that allow them to function under bombardment, depend on the existence of a temporal sequence they can respond to. Time on target eliminates the sequence. German field hospitals documented symptoms in survivors that had no precedent in previous conflict experience. Paralysis triggered by sudden noises, inability to process multiple simultaneous stimuli, a specific terror associated with silence itself, because silence had become the warning that the worst thing was about to happen, and there was nothing to do about it. Unlike conventional shell shock, which could remit with rest and distance from the front, these symptoms persisted after evacuation. Now, the experience of time on target had written something into the nervous system that rest didn't erase. The forensic conclusion, assembled from what happened on July 25th at Panzer Lehr, on August 7th at Mortain in the Falaise Pocket, and in the Ardennes, is not primarily about a tactical technique. It is about what the technique required to work and what it revealed about the organizations behind it. Time on target worked because the Americans could produce millions of interchangeable shells to precise specifications. It worked because their communications infrastructure had redundancy built in by design. It worked because their training pipeline produced fire direction specialists at the rate their system required. It worked because their industrial base could sustain the ammunition expenditure that the technique demanded. And it worked because the organizational learning that developed it, beginning with the honest analysis of failure at Kasserine and continuing through Fort Sill's systematic development program, was built into an institutional culture that treated military effectiveness as an engineering problem to be solved rather than a tradition to be preserved. German soldiers were not less brave than American soldiers. German tactics, in isolation, were not inferior to American tactics. German tanks were in several important respects technically superior to their American counterparts. What defeated the Wehrmacht in Western Europe was not any of the things that German military culture had spent decades optimizing. It was a system, an integrated capability that coordinated production, training, communications, standardization, and doctrine into an organized process for turning artillery resources into guaranteed outcomes. Bayerlein in his bunker on the morning of July 25th was one of the most professionally capable military officers of his generation, commanding the finest division his army had produced. He had no mechanism to defend against what was coming, because what was coming was not a tactical innovation that could be countered by tactical innovation. It was the application of organizational and industrial capability to a military problem at a scale and precision that exceeded everything his army's framework assumed was possible. The silence before 938 was the American system finishing its calculations, every firing solution confirmed, every battery positioned, every shell in its chamber, every flight time computed, every sequence timed to the second. So at 938, the calculations concluded and the system delivered its verdict. Every modern artillery capability, the networked fire control systems, the GPS-guided precision munitions, the coordinated multi-battery fire missions that contemporary armies treat as baseline competence, traces its conceptual lineage directly to what American officers developed at Fort Sill in the 1930s and delivered to Normandy in 1944. The insight that made time on target possible, that artillery is most effective not as a collection of individual weapons, but as an integrated system, is the foundational principle of every coordinated military operation conducted since. That insight cost Panzer Lehr its existence on a single July morning. It cost Germany the campaign. And it announced, to anyone paying close attention, on the specific nature of warfare in the industrial age, that in a contest between a system and the soldiers trying to defeat it with courage and tactical skill, the system wins. Fritz Bayerlein survived the war. In his post-war writings, he described July 25, 1944, with the precision of a professional who had spent years trying to understand what had happened to him and his division that morning. He never found a satisfying answer within the framework of traditional military analysis, because the satisfying answer lay outside that framework. His division was not defeated by better soldiers, or better tactics, or better equipment. It was defeated by better organization, by a system that had calculated, down to the second, exactly when every shell would arrive, and had delivered them all at once into the last moment of silence before the world changed.